Good morning. This is your Stats Sensei, Mr. Spensei, and this is a warm up on battery life. And we're going to run a hypothesis test, but we're going to do the conditions at a later date. So, a company that manufactures smartphones developed a new battery that has a longer lifespan than that of the traditional battery. From the date of purchase of a smartphone, the distribution of the lifespan of the new battery is skewed. That's important. With a claimed mean of 30 months. All right, so they're telling me my null hypothesis is that it's 30 months. At least that's what it sounds like. The consumer group tested a random sample of 60. So in this case, we know that this is six. We have a random sample of 60 from a batch of 100 and obtained an average life of 28 months. So my sample life is 28 months with a standard deviation of 8 months. And we know that the claim is that it is 30 months. All right. So because we have a sample standard deviation, we're going to be running a t distribution, which has the formula t equals x bar, the sample mean minus the population mean divided by, that's supposed to be an s, the standard deviation of the sample divided by the square root of n. Since they gave us the data, it's pretty easy to go, okay, we have a mean of 30. We got a sample mean, an X bar of 28, and we're supposed to be testing to see if it's less than 30, so less than. So we're shading this way to negative infinity. And so on our calculator, that's going to be the button we're choosing. So plugging in, we're going to have t equals 28 minus 30 over the standard deviation of 8 divided by the square root of our sample size of 60. Our inference procedure, well, we only have one sample. They only did this once. They have a one sample, and we're using a t distribution. So one sample, t, and we're running a test, t-test, and we're testing for means. Our hypothesis is what they initially claimed. They're claiming that the true population is 30. Our alternative will always be set up exactly the same. We just need to change our inequality. And in this case, as they said, it was less, so we're going to use a less than symbol. All right, so let's go ahead and run this. We're going to go stat test, drop down to number 2, which is a t-test, mean of 30, standard deviation of x bar was 28, the sample standard deviation, the sample mean was 28, the sample standard deviation was 8, our sample size is 60, and we want to make sure that less than is highlighted. When we calculate, we're going to have the probability that t, because we need to write a probability statement, t, and we have less than there, so t is less than negative 1.9364. And that equals 0.0288. So our p-value is 0.0288, and they gave us an alpha of 5%. So please remember that's basically 5 divided by 100. And by the way, I'm going to label these as months. Just makes it more complete. So in this case, 0.0500. Well, 288 is definitely less than 500. So we're going to reject the hoe or reject the null. So our conclusion is our p-value is our p-value is 0.0288, which is less than our alpha equal to 0.05. All right, so we made the comparison. So our decision is We reject the null. Why? Because we have enough evidence. There is enough evidence. I like to use the word sufficient, but there's enough evidence or sufficient evidence to suggest that the smartphone battery life is, what did we have? Less than 30 months. Okay, please remember, all we are doing is restating the that the suggests that the mean true mean smartphone battery life is less than 30 months. Real important to have that true mean in there, right? Because we're talking about the true mean or the true population mean. It'd be even better if it's a true population mean, right? And this less than 30 months comes from the alternative. So give the meaning of the p-value in the context of this scenario. Well, first off, p-value is the probability of getting a test statistic as extreme or more extreme than what we got by random chance alone, given the null hypothesis is true. Or given the null is true, there's what's the probability? So here we go. Given that the true mean smartphone battery life is 30 months, there is you can put 0.0228 chance or 2.88%. I'm going to use percent, but you can leave it as a probability. A 2.88% chance that we would get a test statistic of 28 months or more extreme by random chance alone. All right. Thanks for watching. Hope that helps. Hope to see you on the next one. Thank you.